Over 500 Republican candidates received more than $100,000 in individual contributions for the 2020 election year. Data collected from the FEC are displayed in the histogram below. If needed, refer to the statistical tool to answer these questions. And we did, right? So we'll describe the distribution. The distribution is unimodal and strongly skewed right. And we can see that. Lots and lots of the data over here. So skewed right. The range you can say goes from 0 to about over 14 million. So we like to give the range as well. Slightly over 14 million. The units there are dollars. We'll use the tool to do some sampling distributions and we'll notice something. So let's pay attention to what happens here. When we go now and look at the data, first of all, we took the data. Here's the data here. We put it into our sampling distribution. Here's what we get. So we put the data here, and now we're going to take some sample sizes. So now we're going to see what happens. So we have the population data, right? And so now we're going to take some sample sizes to see what happens in terms of approximating it. All right, so we want to do sample sizes of size 20 and 60. All right, let me get my face out of the way for just a moment. All right, so now we've got, let's do 20. All right, so now they automatically do, or we'll reset. All right, so now we'll do 20. We'll do 500. So we'll do 100 at a time. We'll put it on 100. We'll draw a sample. And so there is 100 simulations of samples of size 20. And there's the sample mean. And we'll do another 100. Another 100. That's 300, 400, and then 500, right? And what we want to do is we want to take a look and we'll record the mean and the standard deviation for doing 500 simulations of sample size 20. So that's 820,686. And then the standard deviation for this is 274,973. We want to notice that the mean is close to the population mean, as we would expect. And the standard deviation here is 274,973. All right, let's do 60. So that was 20. Let's do 60. So then I'll change this to 60. And now they have done one for us at 100. Let's do a few more. So then, you should notice what happens. Look at the mean. That's for 200. 300. Look at the mean. 400, and then 500. And so then 500 gives us for 60, 844,566, and a standard deviation of 162,875. Let's collect that information over here. So for 500 samples with sample size 20, we got a mean of 820, 686 with standard deviation of 274, 973. And with 60, we got a mean of 844, 566, and a standard deviation of 162, 875. All right. So there's some things to take away here. So we know that the means are close, but the SDs are not, right? And so what will happen is that as you do more and more samples, the sample means for both of these will get closer and closer to each other, but the sample mean for the sample standard deviation for 60 will be smaller than the sample standard deviation for 20. And it's because of something that we're about to say in a few minutes. Right, determine if the conditions are met to approximate probabilities of the simulated sample means with sample size n equals 60 with a normal curve. And so the condition is that the sample size needs to be more than 30. And it is in this case. And so we will be using some normal distribution approximations to answer some of these questions. And so the theoretical mean is going to be the same as the mean we had before. What mean did we have before? Let's go ahead and get it. It is, the mean we had before was 834,857, 834, 857, 834, 857. And now the theoretical standard deviation for a sample size of 60 is you take the population standard deviation and you divide by the square root of 60. So it's going to be sigma over the square root of the number in your sample. So if we take the number, let's look at the standard deviation again. It was 1, 2, 6, 1, 0, 1, 4 divided by the square root of 60. Here is what we get. We get 162,796.2074. Okay. All right, and then we're going to use that to now make some statements about some probabilities. Find the probability of taking a sample of individual contributions for Republican politicians in 2020 and finding an average greater than 1,000,000. So then now if we're using the normal distribution, we'll go here and then we'll put those numbers in. And so I used 2, 1 instead of 207. So, okay, it rounded for me. There's my mean, there's a standard deviation, and there's 1,000,000. And then we want to know to be more than 1,000,000, and it's about 15.52%. And so we'll put that in as 0.1552. Right, so we did the normal distribution with the mean, the standard deviation. And then we wanted to know, we could have done greater than, but the system tells us, both less than and greater than, and we wanted to know greater than 1,000,000. And so they gave it to us. It's just shaded. We could have switched it to greater than, and then it would simply have highlighted what we were looking for. Right, so we put in 1,000,000. Right. So we could have done it that way too. So the system will tell you either way. So we'll put that in. Excellent. Political analysts want to compare the contributions of Democrats with that of Republicans and take a sample of the contributions of 60 Democratic politicians from the same election year. Their sample mean had a mean of $1.9 million. Assume that the standard deviations of individual contributions for politicians in both political parties are the same. Is there evidence to suggest that the Democratic candidates receive more on average in political contributions than Republicans? Well, let's assume things are the same, and then we're going to go back here, and instead of putting in a million, we got a new group of 60, and that group of 60, you know, got 1.9 million. And then we see that that is impossible. If Democrats and Republicans were getting the same, and then we somehow come across some Democrats that got 1.9 million, in the Republican world, that would be impossible. That means that they probably are not getting the same. And in fact, it seems like Democrats are getting more. That's what we'll say. Since the probability of having more than 1.9 million as a sample mean is nearly impossible. The assumption that the Democrats and Republicans get the same amount is most likely untrue and points towards Democrats earning more.